In this video, we'll be looking at chemical bonding. What exactly is chemical bonding? Chemical bonding deals with various attractive forces that joins or holds chemical species like atoms, ions, and molecules together. Let me take that definition again. Chemical bonding deals with various attractive forces that holds chemical species like the ions, the atoms, the molecules together. Now, every atom of element wants to be stable. And for an atom of element to be stable, the outermost configuration must be duet or octet. If the outermost configuration of the atom of element is duet, or duet means 2, or octet, 1, 2, 3, 4. Octet means 8. Now, if the outermost configuration of the atom of element is duet or is octet, that atom of element becomes a stable atom of element. Now, every element wants to be stable. For that, because of that, they undergo reaction so that they could be stable. Now, chemical bonding is divided into two. Broadly, chemical bond or bonding is divided into two. All right. Chemical bonding is divided into two major types. Number one, we have the intermolecular bond. Number two, we have the intramolecular bond. Or is also called the intraatomic bond. All right. Now, these are the two major categories of chemical bonding that we have. Remember that chemical bond or reactions occur, and when reactions occur, various types of chemical bonds also occur. And why do we have reactions? So that each element will obtain stability. All right. Now, over here, we have the van der Waals force. Van der Waals. And the van der Waals, we have two forces in it. We have the London dispersion force of attraction or attraction force. Number two, we have the dipole-dipole force of attraction or attraction force. Then, apart from that, we have the hydrogen bond. Now, all these are examples of intermolecular force of attraction. Meanwhile, van der Waals force is the weakest of all the various types of chemical bonding that we have. But under the van der Waals force is the London dispersion force, which is much more weaker than, or which is more weaker than the dipole-dipole force of attraction. Let's go to the next one. Divide the board. So here we have number one, we have the ionic bond, ionic or the electrovalent bond. And number two, we have the pure covalent bond. And number three, we have the dative bond. Dative or coordinate covalent bond. Then finally, we have the metallic bond. All right, now we're going to examine all these bonds and we're going to find the concept behind all the bond. So we'll start with the first one, which is the ionic bond. Ionic bond exists between atoms of elements, and these atoms of elements have a large electronegativity difference. All right, and the electronegativity difference is about greater than equals to 0.7. So this is atoms of elements, the bond that exists between atoms of elements with a large electronegativity difference. All right, now these atoms of elements is basically metals and non-metals. When metals and non-metals react, this is called electrovalent or ionic bonding. In this case, metals loses an electron and the non-metals gain the electron. So by definition, ionic bond or electrovalent bond is simply a kind or a type of bond that exists between atoms of elements where electrons is transferred from the metal to the non-metal. I take that again. Understand the concept first. You can define it in any form, but understand the concept. If you don't understand the concept, then you have misconception. Now, it involves the transfer of electron. It's simply the transfer of electron from the metal to the non-metal in order to achieve a stable state. Why does reaction occur? So that elements will achieve a stable state. Now, you can also have some Facebook who say the transfer of electron from a lesser electronegative element to a greater or a much more electronegative element, from a lesser electronegative element to a greater electronegative element. And the one they call the lesser electronegative element is the metals, and the other guy is the non-metal. Now, let's give us some example. The sodium. Now, sodium on its own has atomic number 11. The atomic number doesn't change, but the valency number for sodium is 1. You know that sodium is atomic number 11, so it's 2 is to 8 is to 1. Now, the outermost share of sodium has 1 electron, which means it has 1 valency electron. I will draw the structure for sodium, but subsequent examples will use the Lewis structure because of the space on the board. So let's draw the structure for sodium. So this is 1, 2, 3, 4. This is 4. And this is 8. This is 2 for this, 8 for this. And then we have last one, which is 1. So you see that sodium has 1 valency electron. What's a valency? Valency is the combining power of an atom of element, which shows the number of electrons an element is willing to give, lose, willing to receive or gain, or willing to share. All these is in order to accomplish a stable form. Now, we are going to combine it with sodium. At this point, if it's ionized, is going to lose an electron. During ionization, sodium loses an electron. Now, let's say, let's use fluorine or chlorine. Let's use chlorine for now. Chlorine has atomic number 17. So we have 2, 8, 7. The valency electron for chlorine is 7. If you draw the structure of chlorine, you'll find out that we have 7 electrons in their outermost shell. Let's do that. Let's use the red pen. So we have 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So 8 here, 2 inside. So 2 plus 8 is 10. 7 is remaining. The number of electrons remaining is 7. So we have 1, 2, 1, 1, 2. This is 4. 1, 2. This is 6. Now, this is the remaining electron, all right? Now, this is the 7 electron. Now, if you look at the board, for chlorine to become octet, it needs to gain an electron. For sodium to become octet, it needs to lose an electron. Therefore, ionic bonding or electrovalent bonding will occur between chlorine and sodium. So chlorine gains the electron and becomes negatively charged. All right, without much further ado, if you have some textbook on how to combine these two together, all right, so drawing the structure, okay, let me do that because already I've started drawing the two. So now we have that over here we have the sodium combining with chlorine is going to give me the sodium chloride. So the sodium chloride will be like this. All right, this is for sodium and this is for chlorine. Now sodium becomes 2:8. Chlorine becomes 2:8:8. Why? Because an electron has been transferred from here to this point. So what I have here is going to be, the innermost share is 8, you know that. For this one is 8. The one that is inside is 2. You know that already. So what I'm going to do is to just put out the outermost share. So I'm going to be having 1, 2, 1, 2, that is 4, 1, 2, that is 6. So over here we have 1, 2. So this is where the bond is formed. The bond forms between the chlorine and the sodium. Now remember, here is 8, inside there is 2, here is 8, inside there is 2. So we need a duster. Okay, let me put this phone in silence. Let's put the phone in silence because it don't disturb us. All right, so we need a duster. All right, now if we use the Lewis structure of sodium, sodium has valency number 1. In case you don't know how to draw the Lewis structures, check out our video on how to draw Lewis structures of elements. So our sodium to be Lewis structure of sodium is 1, so you can put it somewhere here. So it's going to combine with chlorine. Chlorine has the valency number to be 7. So we have 1, 2, 3, 4. You first of all do it in such a way to distribute the electron first before pairing. So we have 5, 6, and then we have 7. Now the electron is transferred from here, and the electron is transferred to this point. So these electron is transferred from here to this place. So we're going to be having sodium, and then we're going to be having chlorine. 1, 2, 3, 4, 5, 6, 7. Now, the sodium will be positively charged and the chlorine will be negatively charged. So, ionic bonding is just simply the transfer of electron from a metal to a non-metal in order to achieve stability. So, let's do another one. Let's say we have sodium, of course, reacting with fluorine. Fluorine, what's the atomic number for fluorine? E has little bright brain, cannot offer full 9 subject. For fluorine is atomic number 9. All right, so if it's atomic number 9, what is the valency of fluorine? In fact, fluorine, chlorine has the same valency because they belong to the group 7. So now we have 7 valency here. 1, 2, 3, 4. 1, 2, 3, 6, and 1. This becomes 7. So the electron is transferred from here and is received from there. So we have 2 electrons here. What I'm going to be having here will be sodium, and I have the fluorine. 1, 2, 3, 4, 5, 6, 7, 8. Do you understand the trend? The trend is that each of these atom of element eventually becomes octet. This becomes, watch this, this becomes 2 8, this becomes 2 8 8. All right, so this becomes 2 8, this becomes 2 8, because when you add 1 to that of fluorine, it becomes 8 electrons in the outermost shell. That's exactly what is happening there. Let's do another one, which will be the last one for ionic bonding. Every element wants to be stable. So just as you're watching the video, you also want to be stable. But you remember, you can't be stable without being born again. Also, let's look at this. We have calcium. Calcium is having 2 valence electron. Okay, 2 valence electron. Calcium is atomic number 20, so it should have 2 valence electron. 2 8 8. So what is remaining for it to be 20? Of course, this is 16, 17, 18, remaining 2. So we have 2. That means it has 2 valence electrons in the outermost shell. So for calcium, we're going to be having these 2 electrons. Now, these 2 electrons, let's say we're adding it with fluorine. 1 fluorine here, 1, 2, 3, 4, 5, 6, 7. We have another fluorine here, 1, 2, 3, 4, 5, 6, 7. Now, this calcium is going to give out the 2 electrons, all right? And the fluorine will receive the electrons. So what we're going to be having is this will come to this side, this will come to this side. So what I will have, the Lewis structure I will have will become calcium, fluoride. Now, this is now happy because 1 electron is transferred here, is happy, it is 8. Now, this guy is also happy because 1 electron is also transferred to 8. So we're going to be having this, positive 2, negative, negative. All right, so this is all on the ionic bonding. Just involve the transfer of electron from a metal to a non-metal. And let's go to the covalent bond, or the pure covalent bond. Now, for the pure covalent bond, all right, I think I remember something. The characteristics or the features of ionic bond. Number 1 is that they are solid that have high melting point. They are solid that have high melting point. And they can also occur as liquid that has high boiling point. And the solids are high melting point, and liquid are high boiling point. Now, they are conductors, they conduct electricity. They conduct electricity, meaning that they can act as an electrolyte. How do they act like as an electrolyte? They are in an aqueous solution. In aqueous or molten state, the electrovalent compound or ionic compound has what we call free mobile ions. Now, what's the work of the free mobile ions? They are able to conduct electricity using or with the aid of free mobile ions. All right, it's contrast to that of the conductors. If it's in physics, for instance, if you're studying physics, conductors carries current through free mobile electrons for physics, and free mobile ions for chemistry, which is electrolyte, which is also an ionic compound. All right. Now, they dissolve in polar substance. They dissolve in polar substance like water and the rest of those. But they don't dissolve in non-polar substance like the benzene and the turpentine. All right. Now, if you're writing an exam, sometimes I want to just chip this to you. Turpentine Turpentine is used to remove the stain from paint. Turpentine is used to remove the stain from paint. Let me give you another one. You might see. This is UTME question. For those in West Africa, Nigeria, UTME exams, we have some of the UTME questions or JAM questions will ask you which of these is used to remove the paint or the stain from paint. All right, that's turpentine. Now, the borax solution is used to remove coffee stain. Now, turpentine remove stain from paint, borax solution remove coffee stain. Now, finally is the I think is the ammonia solution. Ammonium solution. Ammonium solution is used to remove the stain of grease. Stain from grease. Those of you that work, maybe you work with the mechanical engineer, you fix cars, and then the grease from the oil, crude oil can stain your clothes. You can use ammonia solution to remove the grease stain. Now, that's by the way. That's by the way. If you're writing UTME, take note of that. That's by the way. Now, finally, reactions, if electrovalent compound is in an aqueous state or in a liquid, the reactions over there is faster. The reactions occur very fast if they are in a liquid or in an aqueous state. So we go to pure covalent bond. In this bond, it's just kind of give you the electronegativity difference of the atoms of elements involved. Electronegativity difference is less than equals to 0.5. Less than equals to 0.5. This is a case where element shares electrons between themselves. Now, let's say we have an element 1 which have an electron, another element B which have an electron. This electron is shared between the two, and so I'm going to be having an electron cloud. So this electron is called the shared paired electron. Take note of that. If you go to the coordinate covalent bond or the dative bond, the electron is called lone paired electron. For over here, it is the shared paired electron. Now, this is what is formed there. Now, we have a lot of examples of those. Remember the definition. It involves the transfer, or it involves the equal sharing of electron between atoms of elements in order to mimic the stable state of the octet or the duet. Okay? Now, we have elements, let me list them down. We can have hydrogen, we can have oxygen, we can have nitrogen, we can have chlorine, we can have ammonia, we can have HCl, and a lot of those. The bond that exists in all these are known as pure covalent bond. Let's pick one of those or two to see what is happening in it. Now, hydrogen. Hydrogen has a single bond. Hydrogen has one valence electron. So let's combine two hydrogen. Now, another hydrogen having a single bond. Now, this bond moves over here, this bond moves over here, and then we're going to have hydrogen molecule. Now, what that means, this can be written in this form. So hydrogen has the ability to form a single bond. Let's pick up another example. Any of those? Anyone? Let's do the one of chlorine, of fluorine, of chlorine. Any of those? Okay. Now let's start with chlorine. Chlorine has a valence electron 1, 2, 1, 2, 1, 2, 7, and then we have over here 1, 2, 1, 2, 1, 2, 7. Now there is a sharing of electron between the her and her. So when those electrons, why I say her and her is that it's just non-metals happens occasionally between non-metals. So we have chlorine, a double bond, chlorine, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now you can see that we have 2, 4, 6, 8. 2, 4, 6, 8. They are happy. So they have mimicked the octet configuration. All right, so chlorine is going to form one bond. All right, let's do for the one of nitrogen. I think that might be the last one we do. Nitrogen. What I want to do for nitrogen is that you'll see, towards the end of the video, you see that. Now we have nitrogen. Nitrogen, E has little bright brain, cannot. Nitrogen is atomic number 7. So, if it's in case you don't know you don't know the first 30 elements, we have a video on that. Check that out later. How to name the first 30 elements without checking out your textbook. E has little bright brain, cannot. E has little bright brain, cannot. Not is nitrogen, so it's 7. So, in 7 minus 2 is 5. That means 2 electrons will be inside the first shell, and then 5 electrons will be outside the second shell. So we have let me draw it for you. We have 1, 2, 3, 4. So you see 2 inside and then 5 outside, making it 7 electrons. All right, so we have nitrogen to be distribute the electrons evenly. So we have 1, 2, 3, 4. How many is remaining for it to become 5? Just 1. Just add it over here. Now you see that nitrogen has 1 lone pair electron, 1 lone pair, and then 3 unpaired electron. All right. Now, what is happening? That nitrogen has the ability to form 3 bonds because this guy is looking for 1 to become 2. This guy is looking for 1 to become 2, and this other guy is also looking for 1 to also become 2. So what will they do? What they're going to do is to look for someone to give them the 2. And when they look for someone to give them 2, they're going to look for nitrogen 2. And the nitrogen 2 is going to give them 2. So now, we're going to combine it with nitrogen. Very well. So we have 1, 2, 1, 1, 1. All right. So if we have a 2 here, now this is lone pair. Now these 3 is going to burn together. These 3 is going to burn together. So the bonding will form nitrogen molecule. All right. So I have 1. This is 6 because it's 2. 1. Uh-oh. Be careful. Be careful. Good. So we have 1, 2, 3. 1, 2, 3. And then the 3 of them came together. 1, 1, 1, 1, 1, 1. And then we have 6 of those. And then we have 2 here. 6 plus 2, 8. That's stable. 2 plus 6, 8. Stable here, stable here. Nitrogen molecule has 3 bonds. All right. Now, we can do for ammonia. Now, let's do for ammonia. Then we go to the coordinate covalent bond. So for ammonia, I have ammonia. I want to here. Now it's going to combine with 3 molecules of hydrogen. 3 molecules of hydrogen. Now, if this hydrogen, different elements of hydrogen, bonds each one to this, what I'm going to be having is there'll be 1 hydrogen here, there'll be 1 hydrogen here. There'll be 1 hydrogen here, and then the hydrogen, they will share electron, they will share electron, they will share electron. So what I'm going to be having after the sharing of electron is the nitrogen bond. All right, like this, like this, like this. Okay, the ammonia. Okay, now understand that 1 electron from hydrogen, 1 from here, 1 from here, and then it's stable. All right, now we're going to be having this as my answer for the ammonia. And remember, the ammonia has a lone pair. Look at the lone pair over there. All right, don't forget the ammonia has a lone pair. All right, that lone pair, we're going to use it during coordinate covalent bond to form other bonds. All right, now let's clean up the board. Ooh, I have something to tell you. I have something to tell you. Okay, I can just go without telling you that. Now, the pure covalent bond is divided into 2. Let me clean up this. The pure covalent bond is divided into two. We have number one, we have the homonuclear, we have the heteronuclear. The homonuclear is known as the non-polar, and the heteronuclear is known as the polar. All right. Now let's give it here. Let me use the word polar, and then use the word non-polar. Now, when it says non-polar, non-polar is just that it has only one charge. There's equal distribution of electron. So if that is done, so we can call this homonuclear. So if we say polar, it means it has partially positive charge, partially negative charge. So we can call this heteronuclear. All right, so don't confuse the two. Now, which one should we explain first? Let's divide the bond into two, and let's make some expression. Now, take note of this. Take note of this. Take note of this. And for the polar, for a covalent bond to be polar, the electronegativity difference will be greater than equals to 0.5. For it to be non-polar, the electronegativity difference will be less than equals to 0.5. So now what do we do to know whether an element is polar or is non-polar? We check for the electronegativity difference. All right. Now let's start with let's say oxygen. Oxygen now. Okay. Let's start with a bond between oxygen and hydrogen. For instance, oxygen has electronegativity difference of 3.5. All right. Hydrogen has a negativity difference, I think, of 2.1 something. 2.1. All right, 2.1. Now, what you're going to be doing is 3.5 minus 2.1. So 3.5 minus 2.1 will give me 1.4. So if I have 1.4, 1.4 is greater than 0.5. So the bond here is a polar substance. The bond here is polar. Why? Because electronegativity difference here is 1.5, which is greater than the 0.5. Let me do one more. Let's say we have carbon. What's the electronegativity of carbon? Can I remember that now? I think carbon should be 2.5. If I'm correct, 2.5, then guess, put 2.5 and guess. So this is 1.5. So we have 2.5 minus 2.5 minus 2.1. I think this will give me 0.4. So if it is 0.4, it means it's less than this. All right. So if it's less than this guy will be non-polar. So we have here, let's use an acronym for that. All right. So here is non-polar compound. Here is a polar compound. You see how we got that? Look for the electronegativity difference. If the electronegativity difference is more than 0.5, that's a polar. If it's less than 0.5, that is non-polar. Now let's check out for oxygen. Now let's define this. I said for polar substance, for polar compound, there is an unequal sharing of electron. For non-polar, there is an equal sharing of electron. Now let's talk about water molecule. Now let me make a space for myself. You see, oxygen has an electrovalency number of 6. Valency number of 6. How do I know that? It has little bright brain, cannot offer. Oxygen is 8. All right, 8 minus 2. That will remain 6. So we have 1, 2, 3, 4. Put a 1 here, put a 1 here. Now, oxygen has the ability to form double bond. Because if one from here hold on to another one from here hold on to another one, they will form double bond. All right? Now, but oxygen combining, we want to form H2O. We want to study H2O. We want to know whether H2O is a polar substance or a polar compound or a non-polar substance. We want to know that. So we are going to combine one hydrogen from here and then one hydrogen from here. So if the hydrogen now shares an electron and then shares an electron. All right, the electron is shared here, the electron is shared here. So what I'm going to be having is oxygen having a bond of hydrogen, having a bond of hydrogen. Now we have a lone pair here, a lone pair here. Now normally the lone pair here, we push this hydrogen atom downwards. That's why we have a bend shape or a V shape, so that my structure will look like this. My structure will look like this. So I have, this is hydrogen, this is hydrogen, and then I have two lone pairs. I have two lone pairs up here. Now, the bond here, there is a bond angle here. The bond angle here is 105 degree, all right? And the shape of this molecule is bent. It's bent or the V shape. You can see it's bent or the V shape. Now, the hydrogen will be partially charged, partially positive. The oxygen will be partially negative. All right. So this is non-polar. Why it is non-polar is that we have the electron is not equally shared. This is degree, not an electron. Okay, take note. The electron is not equally shared, and because the electron is not equally shared, what am I doing here? Okay, you understand that this is not, the heading here is not for this. Let me change it for you. So you not say that I thought you that non-polar, it has poles. No, this is polar. Okay, it's just because I've already written on the both side. So polar. Now it has pole. It has positive. It has partial positive, partial negative. The electrons are unequally shared, so we call it non-polar molecule compound. All right. Sometimes, my friends in Nigeria writing UTME exam, I want to give you something that will be helpful for you. Now, you may be asked, what's the shape, what's the bond angle of some of these elements, right? Okay, if you want us to do that for you, we'll do it in a separate video because of lack of time. We'll do it in a separate video. If you want us to do it for you, give us a suggestion in the comment section. If you're writing UTME, you need to know the shape of ammonia. You need to know the shape of water. You need to know the shape of carbon dioxide. You need to know the shape of methane. A lot of those. All right. Now let's give us the features of what's the guy? Pure covalent bond. Number one is that they are volatile liquid. They are gaseous mostly, and they are volatile liquid. Number two is that they do not conduct electricity. They don't conduct electricity, opposed to that of electrovalent. Number three is that they do not dissolve in polar substance, but I have pole, like water. They dissolve in non-polar substance, like the turpentine, like the benzene, and the rest of those. And their reaction in aqueous solution is very slow. All right, so now let's go to the dative bond, or the coordinates. We have a lot of things to cover. Coordinate covalent bond, coordinate covalent. Now, for the dative bond or coordinate covalent, what's happening here is that, pick up that ammonia I showed you. There is an electron known as electron lone pair. Now, this lone pair is given to this guy. So, the electron cloud between them is not a shared paired electron. The electron cloud between them is the lone paired electron. Lone paired electron. All right, so if you have understood that, let's give us an example. Let's say we have ammonia. I've told you how we got ammonia, and the ammonia has a lone pair, and it's going to combine with hydrogen. Hydrogen has one valence electron. Now, the ammonia will transfer this lone pair to hydrogen. So what I'm going to be having is ammonium, but the ammonium will have a positive charge. All right. Now, this ammonium can also further, let's just give you this because we don't know what I will say. Just give you this as a reminder that this ammonium can combine with chlorine. So when you combine with chlorine, it will lose this electron to chlorine then it forms the ammonium chloride. Now, the process of combining with chlorine is known as ionic bond. Now, there are three types of bond here. First, the bond that forms the ammonia, which is the pure covalent bond. Yeah, and then the bond that transfers the two lone pair electron to hydrogen, which is known as the dative or the coordinate covalent bond. And then finally, we have one other bond that transfers the positive charge of hydrogen to the chlorine, which is known as ionic bond. So the three bonds we have explained is happening here. Now, how many of the covalent, how many of the coordinate covalent, how many of the ionic? Now, some textbooks say it's 5, some say it's 6. Drop your answer in the comment section. All right. So let's go back to the board. Let's go back to the board. All right, all right, all right, all right. So this is what we got. So this is all we've got as the answer. So let's do one more. One more. So I have ammonia, hydrogen. Hydrogen. All right, now there's a lone pair here. There's a lone pair. If you check up where if I was talking, you know there's a lone pair here. Now the lone pair will be given out to BF3. So we have, okay, BF3. So the bond that will be formed here will look like this. All right. Like this. All right, so this is the bond now be formed here. Now the bond here, remember I told you, is known as the lone pair. All right, now one of these is a Lewis acid, one of these is a Lewis base. Normally, acid gives out electron, base receive electron. But the contrast is for Lewis. Normally, acid should transfer, base should receive. But the contrast is for Lewis. For Lewis, the acid is now receiving and the base is given. Okay? For Lewis, the acid is receiving and the base is given. So find which one is Lewis acid, find which one is Lewis base. Drop your answer on the comment section. So the next thing to do is the metallic bond and the van der Waals. Well, we are not just a teacher, we are also an instructor. We expect you to go study the metallic bond, research on metallic bond, research on the van der Waals force of attraction, research on the hydrogen bond, and then give us your answer to your research in the comment section. We'll be glad to see that in the comment section. Thank you very much for watching. Thank you for your time. Have a great day.